Section 6.7, Permutations and Combinations. A permutation is an arrangement of items in a particular order. To find a permutation, we can use the multiplication counting principle. That is used when all the items in the set are used. There also is a method to find a permutation when not all the items in the set are used. Let's look at an example. You have 4 seats in the front row of a classroom. A teacher has 4 students they would like to place in the front row. Their names are Ryan, Becca, Sue, and Tom. How many ways can I order the students? Here, we're going to use all 4 students, and we have 4 seats. Therefore, we're using all of the set. And that's what this statement is. Since all the students are to be used and we have 4 seats, then we can use the multiplication counting principle. To do so, it is used like this: 4 times 3 times 2 times 1. The reason is we have at the beginning 4 different seats and we have 4 students. So in the first seat, I have 4 different students I can choose from. On the second seat, since I've already used 1 in the first seat, I only have 3 students left. In the third seat, I have 2 students to choose from, and of course in the last seat, that only has 1 choice. Then, all I need to do to solve for the permutation, or how many ways I can order those students, is to multiply 4 times 3 times 2 times 1, which is 24. So there are 24 different ways to arrange these 4 students in 4 seats. The previous example shows what is called a factorial. A factorial is written as an integer n, and this looks like an exclamation point, in such a way I start with that integer and then reduce down until I get to 1, and then I multiply that order of numbers. So here's an example. I have 4 factorial, 4 times 3 times 2 times 1. And that gives me 4 times 3 is 12, times 2 is 24, times 1 is 24, as shown in our previous example. So that is our multiplication counting principle, also for factorial. Here's another example. For the presidential election, a television studio wants to hold a debate. They had 8 candidates that accepted their invitation. They need to determine what order to place the candidates on the stage. How many different permutations are possible? Since we're going to have 8 candidates, we're going to have 8 podiums, so we're going to use the entire set. That's going to give us the multiplication counting principle. So we can use 8 factorial. And we put that in an expanded form: 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Find the product, multiply them all together, and I get 40,320 ways I can arrange those 8 candidates. If we have a permutation where not all the items are used, the multiplication counting principle or factorial can still be used to solve for that permutation. Here's our factorial method. Here, P for permutation, N is the number of total items in our set, and R is the number of items in the set that are to be counted. And then we substitute those values into the formula, n factorial over the quantity of n minus r factorial, where r is greater than or equal to 0 or less than or equal to n. Let's look at an example where we'll represent the multiplication counting principle and also our factorial for permutation. Here I have 10 students trying out for the 3 lead roles in the school play. How many arrangements can be made for those 3 roles using those 10 students? We have to adjust the multiplication counting principle from our previous examples because we aren't using all 10 students to fill in 10 roles. All we have are 10 students for 3 roles. So we use our multiplication counting principle this way. Our first role, we have 10 students to choose from. And our second role, we've already chosen 1 for the first role. We have 9 left. And finally, in our last role, our third role, we only have 8 students to choose from. And that is all we multiply for the multiplication counting principle. Our 3 roles using a combination of 10, 9, and 8. Therefore, the number of arrangements of those 10 students in the 3 roles is 720. Using the factorial method, we can get the same solution. We just have to identify n and r. Here, n is the total number of items, which is our 10 students. R is going to represent the 3 roles that are available for those 10 students. Then we just substitute those values into our factorial formula. Here we have P sub 10 and 3, substituting in 10 and 3 into our formula. We multiply them out using a calculator and divide, and notice we get the same exact number of permutations for 10 students in 3 roles. Now we move into a combination. A combination is a selection in which order does not matter. We could still use a factorial method, and it's going to be very similar to our permutation. But here I have C, which represents combination, N is still the total number of items in the set, and R is the number that are to be counted. I substitute into this given formula, very similar to our permutation, except I have an R factorial outside of our quantity and denominator. R is still going to be greater than or equal to 0 and less than or equal to N. Let's take a look at our first example. We have a homecoming queen elections that are occurring today. There are 5 candidates for queen, and you are allowed to vote for 3 candidates. We don't care what order you put them in, but you're allowed to vote for 3 out of the 5. How many ways can you vote for the 3 candidates? This is a combination because we don't care how we order them on the sheet of paper that we're voting on. So we have a combination, 5 total candidates, 3 we can vote for, so that is my N and my R, substituting into the formula, 5 factorial over 3 factorial times the quantity of 5 minus 3 factorial. And when I work that out, I'm going to get 120 over 6 times 2, or 120 divided by 12, which gives me a total of 10 combinations. In the next example, the local fair has a horse show each year. This year you have 6 horses that are capable of winning the show, but you can take at most 2 of them. How many ways can you take 2 or less horses? This is a combination because I'm not worried about the arrangement of the horses. But this is a little bit more complicated solution to solve this problem because I have a choice of taking the maximum number of horses out of the 6, which is 2. Therefore, I can have a combination where I have 6 total horses and 2 that I will take, or I could have a combination in which I decide, hey, I have 6 horses, but I'm only going to take 1, or I can decide that I have 6 horses, which I do have, but I'm not going to take any. And I have to solve each combination to completely solve this problem. So let's take it the first one. In the first combination, I'm going to take the maximum number of horses to the show, which is 2 out of the 6 I have. In that case, I have 10 combinations that I can take those horses to the show. The next one, I decide just to take 1. And when I substitute that value into my factorial, that gives me 6 combinations that I can take the horse to the show. And the last one, I'm not going to take any. And when my solution is I'm not going to take any, it's always one choice, which is 0 horses. And this is the complete solution to this problem. Next, I want to evaluate the given expression. Here I have a permutation. I have 7 total items. I have 2 that I need to count. When I substitute in, I'm going to get 7 factorial over 7 minus 2 factorial, which gives me 42. Again, I want to evaluate the expression. Here I have a combination with a total number of items of 5, and the total to choose is going to be 3. And what I have is 4 multiplying that combination. So what I want to do is find the combination and then multiply the solution by 4. And when I do that, I'm going to substitute these values into my combination factorial. And when I do, I'm going to get 120 over 6 times 2. And then I'm going to bring over the 4, which is I'm going to multiply this combination by 4. Therefore, 120 divided by 12 is 10. 10 times 4 is 40. Here, I have a combination dividing a combination, and I want to evaluate the expression. All I'm going to do is substitute the top combination into its factorial, the bottom combination into its factorial, simplify, find the solution for each, and then simplify that. And when I do that, I'm going to get 4/15. Here, how many 5-letter permutations can you form from the letters of each word? So here I have the word factoring. I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. So in my permutation, I have 9 total items and 5 items that I need to count, because that was what given in the problem. So when I do that, I'm going to substitute that into the factorial. And what I get is 9 factorial over 9 minus 5 factorial. And when I simplify, I'm going to get 15,120. I also could use the multiplication counting principle, but not use 9 factorial, because I have 9 letters, but I'm only selecting 5 of those letters to arrange. So what I need to do is my first letter I would select. I have 9 choices, then 8, then 7, then 6, then 5. In other words, 1, 2, 3, 4, 5. And when I multiply those out, I get 15,120. In other words, either method will give me the same solution.